Hello everyone, my name is Yusri. Today, my group members and I will present the suitable method to treat wastewater, which is domestic wastewater in Malaysia. Let's move to the summary part. The domestic wastewater is one of the major sources of wastewater in Malaysia. Therefore, an alternative way is developed to treat the domestic wastewater in order to replace the conventional technique of wastewater treatment. The conventional technique of wastewater treatment is a demanding process. Thus, the microbial cell is the developed method of wastewater treatment. Specifically, the single-chamber microbial cell is selected in this study. In addition, in this study, there are four main points to be discussed. The first one is the suitable method to treat the domestic wastewater. Secondly, the advantages and disadvantages of this type of microbial cell. And thirdly, is how the microbial cell solve the environmental pollution. And last one, the relationship of this microbial cell to the principle of green chemistry. Moving on into the introduction, what is the wastewater? The wastewater is the complex matrix that contains concentration of solids, particulate matter, microorganisms, nutrient, toxic metals, and micropollutants. There are three main sources of wastewater, which are the agricultural, domestic, and industrial sector. Domestic wastewater. Domestic wastewater can be referred as the water used by the community that are being added with the other material during its use. The sources of domestic wastewater are known from the wastewater from the laundry, kitchen, and toilet. The microbial cell can be used to treat the domestic wastewater. In addition, the microbial cell is able to generate electricity through the bioelectrochemical process from the anaerobic oxidation of biodegradable organic substrate. In this study, the single-chamber microbial cell is selected due to its efficiency and high potential in cleaning domestic waste. The further explanation is continued on the next section of this presentation.
The objective of this project are to utilize single-chamber microbial cell SCMFC in treating domestic wastewater, to identify the advantage and disadvantage of using SCMFC in treating domestic wastewater, and to achieve the principles of green chemistry by using SCMFC in treating domestic wastewater.
Hello, my name is Shamil. What is the suitable type of fuel cell to treat domestic wastewater? As an earlier answer, domestic wastewater can be treated by the application of the microbial fuel cell MFC. MFC innovation is considered as another option which not only creates power but in addition aids the wastewater treatments. In brief, MFC are new frameworks permitting environmentally friendly electricity power while treating the organic waste matter through the metabolic cycle of microbes. MFC electricity considerably low and used to light up the LED because it consumes very low energy. However, owing to high installation and operating expense, the MFC are expected to be an appealing choice. Hence, the other acceptable configuration and design of MFC is the single-chamber microbial fuel cell, SC-MFC. The fundamental feature of the single-chamber microbial fuel cell SC-MFC. The working principle is almost similar to the basic ones, but the difference between the single-chamber design with the double chamber is that only a single and not diagnosed as biofilm in which wastewater to be dealt. In this SC-MFC, air is directly supplied to the cathode, hence consuming the oxygen from the environment. Occasionally, to isolate the two cathodes, gas diffusion layer GDL or proton exchange membrane PEM is joined to the cathode. The fundamental feature of SC-MFC are the two terminal anode and cathodes, microbes and a membrane film.
A few advantages of using the SCMFC is the production of alternative electrical energy at the same time are able to treat domestic wastewater. Besides, effective wastewater treatment technology that is both environment friendly and sustainable. So next is the operation of the SCMFC could be energy saving as compared to many other treatment technologies. Lastly is high conversion efficiency from substrate to energy. Nevertheless, there are few disadvantages of using the SCMFC. Firstly is the low electricity production. Next is high internal resistance, and lastly is the current instability.
In order to understand how microbial fuel cell could solve an environmental pollution, we must first know how it works. An MFC has two compartments, which one for the anode and the other for the cathode. And these two compartments are usually separated by a salt bridge or a proton exchange membrane. The process of anaerobic cellular respiration by bacteria will happen in anode, and electrons will flow to cathode through the internal circuit. And the reduction of oxygen will happen in cathode. Now that we briefly understand how an MFC works, let's talk about how it will solve the environmental pollution. Firstly, organisms in MFCs need continuous energy to survive. Hence, domestic wastewater can be a good source of feed as it has high level of organic metals. Based on the research in treating ternary wastewater by using SCMFC, it shows that 88% of chemical oxygen demand is removed. This will help in the environmental pollution because reduction in COD results in a higher dissolved oxygen level which indicate a better water quality. Besides that, MFC can also reduce the consumption of electricity as it's able to produce its own energy. Electricity that are normally produced by burning fossil fuels will release a lot of greenhouse gases that will increase the rate of global warming. Finally, using MFC in treating domestic wastewater will also produce less sludge compared to activated sludge treatment. This will reduce the cost of treatment of sludge in later stage, as well as reducing the environmental impact that might be produced by the sludge.
Hi there, we move to principle of gain chemistry. In the treatment of domestic wastewater using single chamber microbial cells, several gain chemistry principles are followed. First principle, prevention. This microbial cell does not produce any unnecessary waste. It can prevent the release of massive amount of organic compound into water body, lake or pond. Second principle, atom economy. This is calculation for atom economy. This estimate 100%, which is indicate all the reactants are react to form desired product. Therefore, minimal waste or no waste is predicted from the reaction at anode and cathode of the fuel cell. For the third principle, less hazardous chemical synthesis, this improvement is not hazardous because the singular chamber microfuel cell only need wastewater as feedstock and microorganism as the catalyst. Electric current will be produced along with the water molecules as the side product through this reaction. No hazardous product will be produced. Sixth principle, design for energy efficiency. This microfuel cell was designed with excellent energy efficiency. Unlike combustion engine, a microbial fuel cell does not use mechanical energy transfer. It also can generate on the energy through degradation of organic compound. Seventh principle, use of renewable feedstock. Domestic wastewater has a high content of organic compound that can be used as singular chamber microfuel cell feedstock. The microbes can be used again, recyclable in the system whenever the singular chamber microfuel cell is filled with the organic matter from domestic wastewater. For the ninth principle, catalysis, this singular chamber microbial fuel cell system uses a live bacterial culture on the anode electrode surface as the catalyst. The microorganisms applied are entirely responsible for ion electrode production in the fuel cell. Last but not least, 12th principle, inherently safer chemistry for accident prevention. This person transfer the chemical energy content in wastewater directly into electricity, which is simpler and safer to utilize, transport, and store.
So next is the research expected outcome. So the proposed method to deal with the domestic wastewater treatment is by using the single chamber microbial fuel cell, SCMFC. First of all, the single chamber microbial fuel cell consists of air biochar as the cathode, and the reason we choose the air biochar as the material to build the cathode is because it is a low-cost material, so that we can produce a technology that is not too expensive, but at the same time is very effective in treating the domestic wastewater problem. Next is we use a Shawmela putrefaction as the biofilm for the anode. The use of this microorganism is to degrade the organic matter and transfer the electrons from the anode to the cathode, which can generate electrical energy. So lastly is the water-Isin as the biochar catalyst. This catalyst is used because it has a higher power energy output in compared to the oxidation reduction by the platinum or carbon catalyst. The expected outcomes from using the proposed technology firstly is the single chamber microbial fuel cell have two major roles, which are degrading the pollutants and at the same time producing electrical energy. Next is the SCMFC generate electricity from the anaerobic digestion of the microorganisms in the water treatment. Next is the water pollutants can also be significantly decreased using this method. And lastly, the SCMFC is built using a low-cost material as possible so that we can produce an inexpensive technology that can be accessed by all community in Malaysia.
For the budget sections, basically this budget plan is prepared based on our single chamber microbial fuel cell designs. These are the costs that are going to be discussed. For the investment cost, the single chamber microbial fuel cell is constructed with the components such as single chamber plastic glass, electrode material, and a proton exchange membrane as shown below. The total investment of cost is RM228.74. For the investment cost, it is noticed that the major cost for the single chamber microbial fuel cell component is the electrode material, especially for the cathode with 64.64%. Next, the operating and maintenance cost with a total annually about RM43,470.10 was the highest cost among all the costs. For instance, the labor cost is RM655 per person, with the total number of workers about 5 people, which annually costs about RM39,300 per year. Moving on now to the reagent costs. These are the reagent costs for making the trace mineral solutions. The working volume of anode chamber is 105 ml, which is calculated to be 150 ml. There are 35 hours per cycle, 250 cycles per year, 37.5 liters in total. So the calculation shows are influenced based on the calculation I mentioned just now. The recorded cost over a period of time includes the reactor, copper wires, protein exchange membranes with a total of RM20.50. Lastly, the cost per unit power is RM120.29, and the annual net investment cost under practical conditions is RM198 ringgit.
This is our project timeline. Project planning starts from January 2021 until February to discuss the best instrument to treat domestic wastewater. After coming with the cell selection, which is a singular chamber microbial process, choosing the best instruments is necessary. In April to July, the ordering of operative tools for the construction are done using provide budget. The construction of field cells start from July 2021 till March 2022. After the first cell construction is done, it will be tested from March to June before being used officially. Continuous monitoring will be done frequently if any part of the first cell is broken.